Okay, in this video we're going to talk about growth and decay problems like we were doing in class. So our problem is, from the dawn of humanity to 1830, the world population grew to 1 billion people. In 100 more years, by 1930, it grew to 2 billion. And 3 billion more were added in only 60 years by 1990. In 2009, the estimated world population was 6.8 billion, with a relative growth rate of 1.14%. So we want to write an equation that models the world population growth, letting the year 2009 be year 0. So the equation model that we're going to use for this kind of problem is A equals A0 e to the RT. In this problem, A is our amount, or in this case population, after time t. A0 is our initial amount, or initial population. R is our growth rate, and t is time. So our initial population is 6.8 billion, and our growth rate is 1.14%, which is 0.0114. So when we plug those values into our equation, we get A equals 6.8 e to the 0.0114t. Now, based on the model, what would we expect the population to be in 2020? So we know the start of the study is in 2009, so that's where our initial amount comes from. 2020 is 11 years later. So we're going to plug 11 in for t, and we get A equals 6.8 e to the 0.0114 times 11. 0.0114 times 11 is 0.1254, and e to the 1.1254 is 1.1336. And then we multiply that by 6.8, and we get 7.7. So the population in 2020 is projected to be 7.7 billion. Now we want to know how long to the nearest year will it take before the population reaches 10 billion. So we know our equation. That's A equals 6.8 e to the 0.0114t. And we're trying to find t. We're trying to find the time it takes for A to equal 10. So the first thing we're going to do here is divide each side by 6.8. And 10 over 6.8 is 1.47. So we get 1.47 equals e to the 0.0114t. Now, our variable here, t, is in the exponent, and we need to get that out of an exponent to be able to solve for that. So we're going to take the natural log of both sides. And what this does for us is, by the third property of logs, we can bring that exponent down and multiply it by the log. So we end up with natural log of 1.47 is 0.38566, and that equals 0.0114t, which was our exponent, times the natural log of e. And the natural log of e is 1, so we end up with 0.38566 equals 0.0114t. Then we divide by 0.0114, and we get t is 33.83. So we know that it's going to take 33.83 years for the population to reach 10 billion. So if we add that to our starting year, which was 2009, that means during the year 2042, the population will reach 10 billion.